is the recent works we have been doing for a while to support running deep learning workload on Yarn. Yeah, so I'm Wangda. I'm engineer manager of Yarn team at Hortonworks, and I'm Apache Hadoop PMC member. So my major work field is scheduler, deep learning on Yarn, and GPUs on Yarn, etc. So this is agenda today. So first I will talk about the machine learning in production, what the machine learning in production looks like. And also I will talk about for the requirements from data scientists, what the requirements looks like. And also I will introduce the Submarine project with the demo. I will talk about how the other Yarn feature helps there. Also I'm going to talk about the status, plans, and case study from our early users. So for the machine learning in production, if you look at the website from TensorFlow, etc., so they can give you a very easy and quick start guide, such as using the NVIDIA Docker to run the one single command, and you can get an environment. So you can start to play with the machine learning. So this is true, but this is still far away from the production. If we put in the machine learning to a unified platform, so this is one great paper from Google called Hidden Technical Debt in Machine Learning Systems. So if you look at machine learning, it is just a small piece in the chart. So there are some other important things such as configuration, data, and how to handle in the feature extraction, how to handle in the machine resource management, which is Yarn. And also we have to thinking about serving infrastructure, monitoring, etc. So there are a whole bunch of things to do around the machine learning algorithm. So this is a typical data pipeline for the machine learning. So first, the data may comes from edge, or the data is already exist in the data lake. The data scientist needs to use tools such as Zeppelin, Jupyter to do the data exploration. And also, they need to use the tools such as Spark and Hive to do the ETL and feature extraction, split the train and test data set, etc. Finally, they will the data will sent to processed by TensorFlow, MXNet, or PyTorch to do the final algorithm part. So this process will be repeated from the data exploration to the machine learning again and again till the model becomes production ready. And also we have some requirements because sometimes the model is hierarchical. So I can give you an example. So if you want to build Yelp to give the rate to the restaurant, so we can take some comments from the customers about the restaurant or the dishes there. Also, we can take the pictures from the customer to see if the food looks good or bad, and we can put the two things together to make an ensembled model to give the rating. So this is just one fake example, but the similar things needs to be done in many other places, such as when you want to do the predict the CTR click-through rate from users. The hierarchical models will be used often. So I'm going to talk about what's the requirements from the data scientist. So for the data scientist, we have talked to many data scientists when starting this project. So what they are typically familiar with is, first is the linear algebra. They like to do some statistics things here, and they like to do exploring machine learning algorithms and models, and deep neural networks, and basic programming skills such as Python, etc. But if we ask them to dealing with system environment and programming, such as if we want them to develop a Yarn application, they will be definitely unhappy. And also they don't want to understand anything regarding to the resource management, why the job cannot get started, and why cannot access the HDFS, what's the permission of the OS, etc. They don't want to dealing with all of this. And also they don't want to dealing with the networking and storage as well. They don't want to understand any of this. So they will use the tools such as libnear, libfm, and some Python libraries such as the HCI and Kitner, and also pandas, some decision tree libraries such as XGBoost, LightGBM, etc. And also they will use Spark MLlib, deep learning libraries such as TensorFlow, PyTorch, and MXNet. So this is typically how they do the works. So first is where is the data stored? So the data typically will stored in a central data lake, such as HDFS or S3 in the cloud. And this data lake will be shared between team members. And they typically need some distributed pre-processing with MapReduce, Spark, or Hive to get the data cleanup. And once they have data, they need to do some experiments for the machine learning algorithm itself. So what they typically do is to sample from the full data set. They will choose, so the sample means they will just take a small proportion of the data to try to see what happens if trying to use different models and parameters. So they will choose different models, different algorithms, and they will try to tune the hyperparameters to see if the model can behave well in a smaller data set. So what they will do is to use a single node with CPUs or GPUs. So why single node here is, first is the data set is small, and also dealing with single node is much easier than distributed. And last, they will train with the best parameters on the full data set using distributed approach. They will use multiple nodes with CPUs and GPUs there. And finally, they will push the model into serving. So today I'm going to cover, the submarine will cover from the experiments all the way to the serving. So this is our goal. So I'm going to talk about the submarine introduction. So the reason we call it submarine, because it's the only machine which can take human to deep. So as you can see, what the machine learning engineer only wants to see the easy to use part, but below that is all the infra engineer needs to build. So what machine learning, what submarine can do? So first is we want to support running distributed TensorFlow job as simple as Hello World. So the only prerequisite is to set up a yarn cluster with 3.1 and later. So we can run a yarn jar, give the submarine jar, and job run, specify the name of the job, specify what's the Docker image wants to use, where the data stored. Here is stored in a HDFS, and where the job checkpoints will be stored. So this will be used for the TensorFlow to recovery. How many workers there, and what's the resource of each workers? Here we use 2 GPUs for each workers. And how many parameter servers? We have 2 parameter servers here, and we don't need GPUs. So this will be very flexible and powerful for the user to use. Also, we want the user to very easy to view the job history and for all the jobs running. So as you might heard about, the TensorBoard is one of the most frequent tools used by the data scientists to monitoring their TensorFlow jobs. So we can support running one single TensorBoard service and can monitoring all the jobs submitted by the same user. They can easily track the history of their training, etc. And also user can get this application related logs, etc. from Yarn directly. Also, we want to provide a mechanism for the data scientist to get a notebook from the Yarn cloud. We can run a single command, which we can get a Zeppelin notebook or Jupyter notebook, whatever, backed by the GPUs. So they can use this to do the experiments. So I will do the demo later. And also we don't want to only support TensorFlow. We also want to support MSNet and PyTorch. So this part of work is in progress. We can support to do the trainings for the single standalone MSNet and PyTorch, and community is working on to support the distributed version. And this is the requirements for the Submarine project. So first is we want to run the deep learning workload on the same cluster, which already runs the analytics streaming workload, etc. And also we want to enable jobs to easy access job data and models from HDFS and other storage. Also, we want to run distributed TensorFlow easily. And we want to user can specify their own Docker images. And we want to the jobs able to consume the GPU and other resource, such as FPGA recently added into the Hadoop 3.1. And also we want to allow user to use TensorBoard easily to for their training jobs. Yeah, so I'm going to do a demo. Yeah, so first we will. Okay, sure. Yeah, so I'm going to first. So, Fernand, could you help me hold the? Yeah, thank you. Yeah, so this is our latest Yarn cluster, which deploys Hadoop 3.1. So this cluster, we have 6 GPUs installed. We can go to each node to, maybe I should. We can get the GPU information here. So each node we have 2 NVIDIA Tesla P100 GPUs. So I'm going to submit some jobs here. First is let me submit distributed TensorFlow job. So the command is just like what I showed before, except it include few environments required for the Docker container. So let me submit the job. Yeah, so the job is submitted, and we can go to the services to view the job. So we can check the running services. Yeah, so it is started. And we can go to the service. So you can see from here, you can see that we have one master, one worker, and one parameter server. And also we have one TensorBoard component. So from here, we can go to the quick link to the TensorBoard. And the TensorBoard is loaded. You can see that this job is started and running. And also what's the loss function. So data scientists can understand this. They will just go to check the job training status. Yeah, so I'm going to launch a TensorBoard service. So let me try this. So we can run a notebook here, so which we can and get the notebook from the Yarn cluster, just like what you did in the cloud. So we can run this command. Just one single worker, and this worker will launch the notebook. Yeah, so it is submitted, and let's go back to Yarn. And we can click the quick link and go to the notebook UI. And it will take a little while to get started. Okay, so we can check an already running one, so which will be easier. So so this is one already running Zeppelin notebook, and we can use this notebook to do some interactive jobs on the cloud. Also, we can run a TensorBoard service on Yarn, and we. All right. Yeah. So let me just show you the early running one. So it will save some time. It's not running, so I have to submit one. Good. Yeah, so the TensorBoard service is started. We can go to the TensorBoard. So this will take a little while to load all the data for all the jobs. So from here you can see we can view all the running jobs, all the previous finished jobs on the same view. So we can compare different runs. Okay. Yeah. So let me continue my my presentation. So this is for the target feature of Submarine. First is we want to have the job management to handle the start-stop, standalone, distributed, deep learning workload. And also for the model management, we want to handle the checkpoint saved model, and we want to handle the model serving on the Yarn cluster. So this part is work in progress. For the library dependency management, we want to have the bring your own Docker image. And also we are working with community to support they can specify the Python library dependencies without pushing the new Docker image at the end. And for the rest part is handled by Yarn, such as log, job monitoring, and we have best job scheduler in the world. So this is architecture of Submarine. So the user will submit the jobs from to the Submarine command line or REST API, and this will goes to Yarn. So we can have pluggable Submarine runtime can be chosen. So currently in the trunk, we have the Yarn services backed runtime, which we can nicely support DNS and Docker, etc. And currently, LinkedIn, they are working on one project called Tony, TensorFlow on Yarn. They are building the runtime for the Submarine project as well. So on top of that, we will run the TensorFlow job, such as multiple workers and parameter servers. And user can get the metrics from the TensorBoard. So how other Yarn feature helps? So first is we have the GPU isolation. I want to very quickly go through this. We have the GPU isolation. Why we need isolation is because without that, the jobs cannot, if we allocate multiple application requires GPU on a single GPU card, and they will cause the out of memory issue. So we use C groups to implement the GPU, and also we have the we use the NVIDIA Docker plugin to support the Docker plus GPU. So I can skip these details. And also we have the scheduler which can run in very good a bit scale. So with the global scheduling enhancement, currently we can get a 3,000 containers allocation per second. So which means we can have 10 millions of allocations per hour. So this is a 10x throughput gains compared to the previous cluster. And Microsoft, they are using a federation cluster to have a 52K nodes in a single federated cluster. So for the scheduler, since Hadoop 3.1, we have the placement constraint, and the user can specify an affinity, anti-affinity, and cardinality, etc. So this can improve a lot of performance. And this is to illustrate how we run it on Yarn. So let's say we have 5 Yarn cluster, 5-node Yarn cluster, and then we can run the batch workloads such as TADS, Spark, and the LLAP on top of Yarn. And let's say we have some budget to get the GPU node. On top of that, we can run TensorFlow, we can run Caffe and MXNet. So Submarine can manage all this deep learning workload. And status and case study. So for the currently status is Submarine is already merged to Hadoop trunk, and it will be part of Hadoop 3.2 release. And we are still under active dev and testing. Umbrella Jira is Yarn 8135. And the Submarine can run on Apache Hadoop 3.1 plus release. It's a single jar, so it will be very easy to be managed. And we support different runtime concept, as I just mentioned. And currently, LinkedIn just open source Tony, and they are building an adapter to make Tony can run as runtime of Submarine. And this is one of our early user in the community, and that is. So it is one of the largest online game and music provider in China. And they have 6K nodes Yarn cluster currently. They run 100K jobs every day. 40% is Spark jobs. And they run 1,000 machine learning jobs every day. Why it is only 1,000? Because machine learning job typically runs much longer than batch jobs. And currently they are running in a separated GPU Kubernetes cluster, about 500 nodes. So they have each node have from 4 to 8 GPUs. So they have several thousands of GPUs. All the data comes from HDFS. So the existing problem first is they have very low utilization for the Kubernetes cluster because they cannot run the Spark jobs on the Kubernetes cluster. And so on this cluster, the GPU utilization is very good, but the CPU and memory utilization is very poor. And it is very high maintenance cost. Even they have a smaller team to dealing with the Kubernetes cluster, they still think the maintenance is very expensive. And they are working with community to develop and verify Submarine currently on 20 nodes GPU cluster. They reported to us like yesterday, they can run distributed one nicely on the cluster. And they plan to move all the workload to Submarine in the future. Yeah, so this is the source code and documentation directory, and Umbrella Jira. We need your contribution. So, any questions? No questions?
Come on, there's got to be one.
Just a question about the difficulties with running like Spark batch jobs on the Kubernetes cluster where the machine learning workloads are running.
Mhm.
I know that Spark has added native support for running on
Mhm.
Kubernetes. Has the your use case partner looked into that, and did they find something undesirable with using that approach rather than using Submarine? Are there some advantages to Submarine over using the native Kubernetes for
Yeah,
Spark?
so this is a good question. So basically, the Spark on Kubernetes, I can share the thoughts from Spark community. So I talked to some Spark community members, and they mentioned that that one is really hard to use, Spark on Kubernetes. And since Kubernetes, they don't have a very nice scheduler to dealing with the batch Spark jobs, such as quotas for queues, which we have for Yarn. We almost have that from the first day of Yarn. So I think running Spark on Kubernetes in production will be a long journey. Yeah.
Okay, thanks, Wangda. Oh, wait, one more question.
I don't know all that much about machine learning, but does Submarine do something specific when it comes to container preemption and things like that? Because you would expect these containers to run for a long time. So does now Yarn have an insight into, okay, this is something that I should not kill? Does it have any kind of affinity?
So currently we don't need that. One of the reasons is machine learning, they will frequently to write all the snapshot to the HDFS, so they can very easy to recover. So preemption a job is so this job will running typically for several days or at least several hours. But preemption this jobs is not that expensive because they will lose a little bit of work, but not much. So Submarine currently is you can think it's more like an application instead of building more things to Yarn. So if there's any common layer we need to improve in Yarn, we will directly contribute to Yarn.